Climatics. We're from London. My name is George, I'm the CTO. This is Chris, an engineer at Climatics. We're going to be talking about ION, our interoperability framework. So Climatics is a blockchain infrastructure technology company focusing on protocols. We have a heavy interest in privacy, interoperability, network economics, and consensus. We predominantly work in the private and permissioned blockchain space, and we're a member of the Ethereum Enterprise Alliance. Our major project is the utility settlement coin, which is a project founded in 2015 with UBS, with a goal to tokenize cash assets held at the central bank. We're working with several central banks in multiple jurisdictions, representing several currencies, and the project's aim is to improve capital efficiency and reduce systemic risk in the market. We're also very interested in the benefits that decentralization can bring to financial market infrastructure. We recently coined a term called distributed financial market infrastructure and have begun writing some pieces on our blog. What we see is the goal of decentralization can reduce systemic risk across the ecosystem. We're really looking to reduce the single points of trust and the single points of failure within the system. So at the moment we're working on the cash leg, so the settlement and payments end. But we see that there's going to be an evolving ecosystem of tokenized assets, of securities, of many different financial instruments that ultimately will need to settle in cash. So this is why interoperability is of interest to us. So we perceive that there will be many different networks, some representing securities, perhaps some representing trade agreements, but that for us to be able to transfer the fiat leg, the tokenized fiat leg, we need to have a truly interoperable world. So I'd like to take you back to the 19th century in England for an analogy that I think is very relevant to the current situation. So around 1825, the first private railways began to emerge in the UK, and they were run by private companies, so they were transporting goods and people. And basically the gauge that the trains ran on were different for each private operating company. So when you got to the end of a railway line, you had to get off the train and go onto another train, move the goods onto another train. So it was very expensive, and it wasn't possible to drive a railway all the way through the country. So this was recognised as being a problem, and there was an agreement to standardise the width of the tracks to 4 for 8 inches. And what this meant was it was very much cheaper to transport goods and people throughout the land, and that the economic activity increased exponentially. So this analogy is interesting for me because it represents an analogy with payment rails, but also that we also have private companies who are trying to create interoperability solutions and products that are often based on tokens and require you to buy into an ecosystem. Standardization is happening in interoperability. For example, the interledger protocol is a good approach for payments. We're also interested in state transitions, so we're working on that too. The Chinese government have started to standardize on blockchains. We heard from the ISO body earlier about some efforts there. So what would you do if you wanted to transfer value across jurisdictions? And I'm talking now in the fiat context as well. So you could just use Bitcoin, and this is the maximalist view. And the world that we work in, the highly regulated financial markets, this doesn't particularly work well for us. It works for payments use case in the retail space, but it doesn't really work for other asset classes, and we need utility. We still need to check out to fiat at some point. We could centralize on centralized exchanges. I talked earlier about our goal of decentralization, so this isn't really aligned with our vision. It has some privacy problems. It's pretty hackable, so we've seen some really large-scale loss of values with Mt. Gox, Bitfinex, and CoinRail, and it's not really aligned to the grand vision of Web3 and what we want to achieve. You can bridge to cryptocurrencies, so there's Ripple, XRP, and a few other approaches, and this is a viable way to move from one currency to another. But again, in a regulated context, there's some questionable properties of this currency. It's very volatile. And furthermore, the Ripple network is fairly centralized, both in governance and in terms of validators. There's also some interesting interoperability possibilities from the scaling approaches. So we're seeing in Plasma, for example, there are some interesting tokens like Amaisigo, which aim to be the token that flows through a Plasma ecosystem of root chains and child chains. And you can certainly transfer value using that. However, staking is part of the design, it's tied to the Ethereum ecosystem, and it offloads computation to child chains. There's also protocols, so at a very low level on the internet, the TCP versus TCP IP level, and there has been some thought of extending those and trying to make a blockchain low-level protocol. There's also been some work from the WC3 on standardizing a payments standard, but this hasn't really been focused on blockchain. Then we come on to the commercial entities, so we heard earlier from Cosmos and also Polkadot and OneLedger. Our question here is whether they really offer an open ecosystem. So it requires you to buy into a token, to buy into a particular protocol and a particular approach. So this is why we wanted to take a slightly more agnostic approach and to try and build a framework that can support multiple consensus engines, multiple protocols. And for us, of course, settlement finality is extremely important in a regulated context. So this is why we decided to create ION, an open framework that isn't tied to a token or an ecosystem. And I'll pass you over to my colleague now, Chris, who's going to introduce it to you.
Thanks, George. Like George said, what have we learned really from these previous existing projects that advise our thinking? So we've been working in interoperability for a few months now, and we've taken some lessons and approached it in a slightly different way. So we'd like to introduce ION, our interoperability research project at Climatics. Like George said, we wanted to make it so that it was a light protocol that wasn't bound to one ecosystem, it was open enough to facilitate interoperation between different blockchains. Currently we're focusing on EVM-based chains, but the design of it makes it so that we can interoperate between different blockchains, Turing-complete and non-Turing-complete blockchains. We've only just released ION Stage 2, which encompasses our new design. How have we done this? So our approach, one of the key notions of our approach is that it has to be a light protocol. We're not re-engineering a protocol, which makes it agnostic to use case, and that gives us a lot of flexibility in terms of the way we can apply the framework. Another notion that's really important to us is finality. Finality is basically probably one of the most fundamental concepts of interoperable systems. If the state needs to be passed between two interoperating systems and interact based on that state must be final, otherwise we're going to have finality issues basically. So our design was focusing also to maintain and be able to handle different finality concerns of possible different blockchains and their governance rules. Like I said, we do a second layer approach. We don't modify their protocols, so the ION is designed as a set of smart contracts with a different architecture to allow agnostic approach to the way that people can implement their validation schemes and the way that blocks may need to be validated depending on what blockchain we're interoperating with. So we do separate validation from blocks from verification of state. And with this design, we also push forward to try and make it an easy interface for developers to develop their smart contracts to interoperate between chains and users to use them. So what do we see as one of our use cases for this? Like George said, we work in the financial markets, and one of the use cases we see in our ecosystem would be a cross-chain FX option. So if you imagine we have two currency chains, one that settles denominated in USD, and one that settles denominations in GBP. And then we have a third chain where smart contracts that detail option contracts will be deployed. Separate chains, they wouldn't be too useful, because if an FX option agreed on the FX option chain was to be exercised, that would need to be settled and denominated in agreed currencies. So with ION, and in our network, to be able to interoperate between these systems, perform contract agreements and then settlement on separate chains allows us a really powerful system, and ION will support this. And how to do that? We use an event consumption model. So simply put, events would be emitted on one chain, which would then be consumed and arbitrary computation performed upon consumption of that event. With that event, state can be passed with it, so we can have one chain consuming an event to draw dependence on state and events, whether or not they happen on another chain, to then perform something else. What this allows us is something we call continuous execution, where a series of chains and smart contracts can be emitting and consuming events in series and we have kind of this interoperable network of blockchains, which gives us the lush ecosystem that we so look for. So this is the generic ION framework. The architecture is on blockchain A here, so for us to consume an event from blockchain B on blockchain A, the stack consists of 3 discrete layers. So as you can see, we have the validation layer. So as blocks are submitted, and the validation contract would then, depending on the schema of validation, depending on the originating chain, it would check the block for correctness with some finality guarantees. And then our second layer, once it validates properly, it will be submitted to our block store contract, where those things are held on chain. And then when it comes to proving a state transition or an event, that event consumption contract is a use case contract that developers would develop themselves, and that would query the block store contract for verifications. So let's talk about each of the layers in depth. We'll start with block validation. So in order for one blockchain to interoperate with another, there needs to be some passing of state. And that's done so when a block is mined on one chain, that block is then submitted to the other chain, and this goes through via the validation contract first. So what the validation contract needs to do is replicate some of the governance rules and finality characteristics of the consensus algorithm on the originating chain, verify the block is correct, and then once correct, it can submit it to the block store contract. It's really important because the way that event consumption happens, it must ensure that any submitted blocks are indeed final and are correct, otherwise event consumption will be false and maybe there will be double spends. So once blocks get passed through to validation and they're confirmed to be valid, they then get passed on to the block store contract. So once they come through, the validation contract says, okay, this is the correct block with some finality guarantees. Only then will it pass it on to the block store contract. So this contract then receives submitted blocks, would decode the block structure depending on which chain it came from, and store the useful information. So for Ethereum, we'd store transaction tree roots and receipt tree roots, which are the components that we need to prove state transitions and events. And submitting a proof to the block store for a given block would then prove that a state transition did happen in that block. Which moves on to our third layer, the use case contracts layer. So with our first 2 contracts, now that we have submitted block, use case contract can be developed and deployed to prove that state transition and the event did happen in a certain block. And with a proof to a function call, then prove that that did exist in the block and then execute a function. So what this allows us to do is developers can develop their own use case contracts that consume any event that happened in any block. So the general flow through the architecture would be an event gets triggered and emitted on blockchain B. The transaction that happened in then gets into a block and mined. Then that block gets submitted to blockchain A via the validation contract. Validation happens, submits it to the block store contract. Once that block is now stored and ready for checking, a use case contract would query the block store contract with a function call and a proof with that event having been triggered in that block in the certain transaction. And once that gets verified true, the function executes. And what we've done there is we've been able to execute a function and perform a state transition function on blockchain A, dependent on state and events from blockchain B. So with that knowledge, how does that apply back to our initial use case of the FX function? So with our 3 chains, if we wanted to exercise an option in an option contract on the black chain, that would be a function call on the smart contract. Once that gets exercised, an event gets emitted and into a block. Step 2, that block then gets propagated and submitted to both currency chains, red USD, blue GBP. Then the event of that exercised option gets consumed on both chains, so now both chains would hold information about the exercised option, the people involved in the trade, and the terms. From that, a cross-chain atomic swap would occur across those chains. So that would be a separate use case set of contracts that would perform a cross-chain atomic swap, but would use data from another chain pertaining to the agreed FX terms. This is really important to us because what this proves is that we've created an interoperability framework that's agnostic to use case. We can develop any kind of use case, and most certainly that it supports the ecosystem we see at Clearmatics in a financial market infrastructure context. So let's hand it back to George for wrap up.
Thanks. So to summarize, ION is an open and extensible framework for interoperability, designed really with our use case of financial markets in mind, but is applicable to public and permission chains. We don't make any assumptions about consensus algorithms or indeed the function that's executed after that. We've tried to create a simple interface, and we believe it's backwards compatible and also future compatible for things like Casper and the friendly finality gadget when that eventually comes around. To reiterate, we're taking a second layer approach, so we're not a token, we're not an ICO, and actually the interoperability framework is completely open source and has no commercial interest behind it. We welcome feedback from you. The source code is available on GitHub. We welcome peer review, we welcome contributions, and we're also hiring in London and around the world. If you're interested in finding out more, visit clearmatics.com/careers. Thank you.